All right, you guys, let's get started. Welcome this morning. My name's Scott Dinsmore, in relation to the drummer from The Doors, for those that get that. I'm a development lead on Visual Studio. And today we're going to talk about some tips for building Windows Store apps with Visual C++, and XAML. And this, a little bit about a background about Hilo. Hilo was a project that I used to work on a team called Patterns and Practices that we kind of did a collaboration with the Windows team to build out a real-world application using C++ and XAML as a Windows Store app. And we actually had a previous Windows 7 version of Hilo that we did quite a while ago, and we said, just like Windows 8 is a reimagine of Windows, we wanted to reimagine what that project would be like on Windows 8. So we decided, all right, let's do that. We're going to build it in C++. We're going to use XAML. We're going to do all the new modern C++ advantages and take advantage of it. And we built this team and said, all right, we're going to go out and build this. And this is kind of the tips that we learned along the way as a team of people building a real-world Windows Store app application. So it is an end-to-end photo sample app. And it's providing guidance on how to build these Windows 8 apps with C++ and XAML using modern C++. So we take advantage of all the C++ 11, all the new PPL, everything that we could take advantage of to help us build this Windows 8 app. And this guide is really there to help you guys, because I'm assuming a lot of you are C++ developers, at least I hope you are, get ready to do that and understand how this kind of changes the world that we live in today. So this is kind of a pseudo architecture of what the world looks like now. So we have the same thing. We had an OS process now. We still have all the Windows kernel services. We still in this new world we still have access to some of the Win32 and COM. We get access to the modern C++ 11 with the STL, and we still have access to a lot of the C runtime functions. We have PPL, which is the parallel programming library, which we can do and use for asynchronous tasks, which there are a lot of in Windows 8, if you've taken a look. And there's also this thing called a Windows runtime, which is really this application boundary interface that allows all the languages to talk and gives the visual style and the touch language that we have in Windows 8 and exposes that for everyone to use. And then we still have C++. I mean, you can still use C++ in your Windows 8 app, but I'll show you that. And we have these new things called ref classes. If you see the little hat symbol, which is I'll show you soon, these are these guys, and they're mainly built for interop so that you can kind of expose your things to, just like the Windows runtime does, it's kind of this application boundary interface that you can expose whether you're writing components for other languages to use or you're just exposing it to XAML. And again, we have this new declarative language called XAML. And if you've ever done WPF or Silverlight or done .NET programming, you probably have seen XAML before, and it's pretty much the same thing. And that extensible markup language kind of lets you declaratively define your views. No more like writing dialogues and create window and hwins all over the place. This is a more modern way of building apps. In fact, I like it a whole lot better. And we'll see that. So I want to show you Hilo, just to kind of give you an idea of what we'll be talking about through here. And you can see this is Hilo. We've got it's got its own live tiles, and I've got some pictures of when I went to Berkeley, the Visual Studio box in the middle of Building 41. But what I want to do is I want to go find a picture of the I think I took it about in May of the space shuttle. And to do that, in Hilo, I can go out and I can get all the pictures. I kind of can show, and we kind of show this each one by month. But instead of me kind of flipping through and scrolling all through these months, I'm going to go to a different view. And I know it was in May 2011, so I'm going to, and you can see we use some visual ways of saying, here's the things that have pictures in them, the things with white, they don't have pictures in them. So I'm going to go to May. And oh, there it is. I can see, here's a picture of shuttle launch. What I want to do with this is actually kind of do some effects to it. And what we allow to do is do a lot of effects. And I can go look and see. I can still see all of the pictures that I have in here, Bazinga, with all my kind of a film strip view of this. But I want to actually create an effect on this guy. And it's just like a cartoon effect. And I'm going to go ahead and just preview so you can see that, because I want to send this to a couple of friends. And we're going to use AMP to actually create a cartoon effect. And we decide whether we're going to use PPL or AMP or something like that based on whether the hardware acceleration is an emulator or a real GPU card that we can use. And you can see pretty quickly I can apply a cartoon effect to this really cool picture. I think it's kind of cool. I'm into kind of spacey, geeky stuff. And so I can do that and send it to my friends, do whatever I want to with it. I'm going to cancel out of this. And you can see it's just a basic Windows app that allows me to do these things, but it's a photo editing, and we use C++ to build it all. So let's go back over here to the talk, and we'll talk about this. We're going to get started on the journey of actually how we built this app. So I'm going to walk you through this in a series of tips. And this is kind of the journey that we went on as a team of how we built this app and what we learned. And a lot of the tips that we picked up along the way, and I'm going to kind of break them up for you. And these are kind of the first ones, was the C++ tips. Some of these are going to might be new to you, might be old to you, but one of the first things that we learned to do was use stack-based semantics, smart pointers, and the resource acquisition is initialization. Like, this is a new way. All the new pieces of C++11 allow us to do this. So this is, to me, when I was doing C++, and I'm old, so this looks right. Well, it doesn't look right to me because there's a lot of problems that we can see here. But the old way of doing this is I've got a widget, and I can new it up, and then I do something with it, and then I delete it. But there's a lot of problems with this. What happens if draw throws an exception? There's all kinds of weird things that can go wrong that I can lose all that memory. And a lot of this stuff has been around with like boosts and things, so these are not new things. But now it's built right into the platform, and you can do these things with all of STL. There's the shared pointers and things like that. And smart pointers make this pretty easy. So I can just say, now I can just new one of these up without newing. I can just say, make a shared pointer for this guy, and I can call it, and I get no leaks, exception safe, everything, because I'm using these stack-based semantics with these smart pointers. And when you do this with Windows runtime components as well, it's the same thing. So the Windows runtime components, you actually new up, and you use the keywords ref new when you new these guys up, and we'll see a little bit of that later. That when you do that, they're kind of auto-reference counted. So if any of you guys have done COM before, you remember you used to co-create instance on these guys, and you say add ref, and then you do a bunch of stuff with it, and you call release. And then we created all these things called like CCOM pointer and ATL and all that other stuff. There's actually the same things. If you still want to do COM pointers as well, you can still do that in this new based world where you have a CCOM pointer. But now we're using the Windows runtime library. And a lot of these features are in there that allow you to use these smart pointers everywhere so that you can still use your stack-based semantics. And again, we can still use the resource acquisition pattern that we can say, all right, I'm just going to new up a new widget. I'm going to pass it into my class, and my class is responsible for cleaning that up. We have unique pointers as well that I can create a new widget in it, and it will take the responsibility of cleaning that up as well. So a lot of this, and you can see before I used that auto keyword. So we used C++11 and the auto keyword. We took advantage of that everywhere we could. These are kind of the ways we took advantage of the modern C++ style of programming in Hilo. And this is a little bit small. I didn't realize it was coming out small. But the big one is use public ref classes for interop. So there is a cost to doing ref classes. And ref classes are these things that you expose as Windows runtime. So what we did was we created these ref classes as the kind of ABI boundary. I'm going to use that word a lot probably. This application boundary interface that says, all right, we're only going to expose things out to the world as these ref classes that we want people to use. And a good tip that we learned to do that is only make those public. Because if you're using an internal class that's a ref class that's internal, you're probably using it the wrong way. I granted there are the exceptions to all rules, but most of the time you're using it the wrong way. And we learned that the hard way, is because we did a lot of stuff that was internal ref classes because it makes it really easy to do things. But there is a lot of stuff going on behind the scenes that the compiler is doing for you that when you pass that to the compiler, you basically go, all right, I get the ref class for not for free, but it looks like I get it for free. So use those only for interop. And a lot of that interop is if you're binding to XAML or doing anything with XAML, you have to kind of use these public ref classes. If you're exposing a component that you want other language to use, you would expose this to public ref class. Other than that, use regular C++ classes. They still work. Everything is going to work just fine. Most of the model stuff that we do, and I'll talk about a little bit about that we did is C++. so that we get the advantage of using C++, but we only expose the things to the boundary layers that we as ref classes. As you can see, we also did some interesting things, and it's probably kind of hard to see, but we use even internal stuff to so we could do testing without making them ref and call things without incurring the overhead of ref classes that we have internal, like concurrency tasks and things like that, so that we could still use C++ because you can't expose C++ idioms in your public ref class because they create this metadata file that all languages do, and all languages don't know how to deal with shared pointers or concurrency tasks. So we actually made those all internal so that we can do it, and we only exposed what we needed. So async, you heard me talk about PPL. Async is everywhere in Windows 8. If you guys have had a chance to play around with the APIs or not, before, you remember when you were like opening a file or doing anything, when I remember back when I was doing desktop development in C++, it was pretty easy. I'm just going to open a file, and I wait for it to open, I read it in, I do some stuff. But what happened was all that stuff I had to figure out either how to get off of my main thread because, hey, the user has to wait forever. And nobody likes waiting around. Nobody likes getting the little cursor, hourglass cursor, or whatever your cursor is, and says, oh, we're going to wait forever to read this big 2 gig file. But to do that, now Windows 8, basically it's just for example, whenever you open a file, it's open async. Everything ends with this word async, and that's how you know it's an asynchronous operation, and there are a lot of them. So these PPL allows you to kind of work with the Windows runtime versions of async, which they expose as an iasync info object, or these tasks, and wrap them up in these tasks from the PPL. And the first thing we learned the hard way is don't create circular references between your ref class and your Lambda expressions. So when you're doing async tasks, you probably have some kind of callback or Lambda expression on a then statement of a task. So when you do these tasks, you go, hey, I'm going to create a task. Whenever that task finishes, then I'm going to do some other operation, and I do some Lambda to pass it a function pointer that basically allows me to do this. And these Lambdas we use these everywhere. But you can see here that if I did not create a weak reference, and this is a way of saying don't add ref that object, there was no easy way for me to stop the Lambda from add refing it, because that Lambda just basically takes and builds up kind of a function, and it will kind of add ref and new up the things that it needs to, so that it kind of holds onto it with these ref classes. And it says, all right, I'm going to add ref that thing that you passed to me. So if I just pass this in there, there would be an extra add ref in there with no release. And there's no easy way to do add ref and release. It's all done for you. So there's no way for me to just call release on the thing or dispose, because you can't. And what would happen is there's a extra reference to this guy, and guess what I end up with? Memory leak? Anyone? Which is bad. So whenever you're doing something with these references that you're passing around, you still, even though it makes it look easy, you still have to think about whenever I kind of assign this thing, I'm getting reference counted. So I'm kind of incrementing that count. So sometimes I have to remember to go, oh, by the way, most of the time it just works, but in these Lambda cases, remember, because you don't see it, that thing is actually making a copy of it, or an add ref of it, and it will then create that add ref and keep around that for you. Using the explicit captures for Lambdas. Again, this is a lot of code on here, but what this does for you, what we're saying here is, everything, if you don't tell the Lambda what capture you're going to do, you have these standard, or you have like a bunch of variables. Like right here I see in I and j. Well, what if I had like 12 more variables there because I have this big long function, which is not a good thing, but sometimes you have to. And then I can then just say I want to capture everything by reference or I want to copy everything. Think about what that function would do if I said everything. It's going to take all those variables and copy them. When actually all I need, if you look at the very bottom, is I and j. That would be bad. That would be bad. You don't want to copy all those variables or add ref all those variables or figure out if it's going to be a weak reference. So be very explicit. I like being explicit because I kind of treat my code a way of saying the person that comes along after me is probably an axe murderer, and if they get really mad at me, they'll kill me. So I don't want them to come find me and go, you wrote this code and I don't understand it, so do that. And task escalation. When you're doing asynchronous calls and you're doing these things, you saw when I showed the app, you might have seen that we allow you to cancel any operation that we do. And that's something you want to do in these apps. You want to give the ability for the user to cancel it. You could have, because also you could get suspended or terminated in the app, and you need to cancel that operation. You need to just have that operation cancel in the middle of it. So you want to be consistent about this. So you want to create these cancellation tokens using the PPL and actually get that token and pass them along as you create tasks and pass them along to there. Now, the cool thing about this is when you do this and you also do things within the Windows runtime, those cancellation kind of tokens go along and kind of flow along, even though you can't pass them into the Windows runtime things. When you use PPL, they just kind of go along with that, so that if they do cancellation in there, they will trigger that cancellation token to be canceled. And then when you come back, you'll want to check, hey, if this thing got canceled or not, I need to stop this operation. And it's a good idea to kind of check before any long-running operation and after any long-running operation that, hey, did somebody cancel this, yes or no? And this one is a big one. This one killed us. Be aware of context rules. And what I mean is, like, what thread am I running on? And man, did we struggle with this one for a long time. Because it's very, very important. Just like before in Win32, there's certain operations that you have to do on the main UI thread because that's window operations that you have to do on the main UI thread. It's the same thing here. There's sometimes you can do things on a background thread. A lot of times you have to do on the UI thread. And you can see, like if you see that little assert statement in there, is background thread and is main thread. We wrote those, and I would guarantee you that all of you want to steal that code if you write Windows 8 apps in, because what this allows you to do is assert that what you think is happening is really happening. So let me explain that. So if you look at this kind of how task and continuations work with the PPL and in Windows 8 and the Windows runtime, so whenever I create a task, and I use an iasync info, so like this guy, this get photos for data range underneath the cover is actually calling some file query API, and it actually returns an iasync info object that we're going to run, and it says, all right, I'm gonna whenever I run that, it's going to run in the context of which it was created. So if I'm creating this in the main thread, that thing is going to run in the main thread. But you can change that when you pass a variable to the then statement. So you can see where we say task continuation use arbitrary, task continuation context use arbitrary. We're saying just use any arbitrary thread from the thread pool to run that code in the then statement. So it will run that task. It will then run anything back in the background. And we use that assert is background thread to make sure that we actually did that. Then on the next then statement, it's going to switch back to the main thread because it's, again, using that context that it was created with. And it says, all right, now do something in the main thread. We assert that we're in the main thread. And then the then statement we do again because we don't pass anything. You could be very explicit and you could say, pass in, use current context, I think is the right one. I can't remember off the top of my head. I used to be much better at that, remembering things. Now I'm getting old. But that's the way you can say, all right, always use that context. And we use those assert statements everywhere because this one killed us. Because when you run things on the main thread, it became very slow. Like the app was slow. We couldn't figure out why. Well, that's because we didn't understand the context rules. And once we understood the context rules, we could assert all the things that we knew were true, and then the app run much, much faster. So now we're going to switch a little gears and talk about pages and navigation. This is where we talk about a lot about, this is where we start talking a little bit about XAML and the views. So we've kind of talked about C++ and a little bit about task and async, which is still C++. And now we're going to talk a little bit about how we do pages and navigation. We spent a lot of time talking about how the model of the app interacts. So any app that you build in Windows 8, I would recommend, and this is a free tip, spend a lot of time about how you think the interaction is going to be, because we spent a lot of time going back and forth on that, talking about how we think the thing should work. And this picture here actually represents one of the pictures that we drew on our whiteboard. And one of the things that we learned along the way is you're going to get free things from the templates that ship with Visual C++. And one of them is called Layout Aware Page. Learn it, love it, use it. It provides you a lot of things to do navigation, state switching, and lifetime management. The team really tried to make it easy for you to build these apps and get a lot of things out of your way. So all these things I've listed here are things that you can use to either go home, go back, go forward, how you deal with state transitions. Because when I say state transitions, think about all of you, I'm assuming all of you, that's got a surface, which I didn't get a surface. But anyway, Saw my first one in the wild today, which was awesome. But you can think, all these states that you can put the thing in. I can flip it, the orientation. I can take that and snap that to the side. All these are state transitions that you have to deal with and that you need to deal with. And so you need to know, like, when did the person actually change the state? Well, a lot of that code's written for you. You just have to respond to it, which is awesome because I remember having to write a lot of, remember when you had to like worry about people resizing in different monitor and resolutions and all that craziness that happened? If you ever wrote any Win32 desktop apps, that was never fun. And then remembering how to save state and putting all the right, like put it in the registry or in any file, like where all these things goes. Yeah, no more of that. All this stuff is handled for you, which is really cool. And one of the things you can do in this navigation is you can do this in XAML. So if you look at, and this is new to XAML, or if you've never seen XAML before, XAML is just like XML. It's a markup language, and it kind of describes what this. On this page, we're just saying, hey, this is a Hilo page. I'll explain that in a little bit. And this is a button. And this is actually that film strip that I showed you at the top where we saw the Bazinga and all the different pictures in May. This film strip back button actually is that little back button up at the top. And whenever someone clicks it, it just invokes the go back. And that's all it needs to do. There's different ways of doing things in XAML. We'll talk a little bit about that. But I'm basically saying, just go back. And that was for free. I got that one for free. And I can just basically go back and forth and navigate through the app with these functions that they have in there. I can also do it in code. So I can, again, you see the assert for the is main thread. We always want to know that. We want to, because a lot of times what we're doing is we're initializing things on we're doing it asynchronously so that the UI stays really responsive, because fluid and responsiveness is a big thing in Windows 8 and these store apps. And then we're basically saying, hey, I'm just going to go home if the photo is null. So like because you can imagine this crazy idea. What happens if you selected a photo, you suspended the app, and then all of a sudden you're trying to initialize back to that same photo, but you went to the file system and deleted it? What would you do? Well, we just go home. That was our decision. It was like, that was kind of an arbitrary decision, but that's what our decision was. But these are the things you have to think about in this thing. And this is, again, this is a lot of learning that we did through building this app. Support all the states. You're going to get a much better experience. Because what we're really talking about here is we want you to build apps so you can make money. Remember, this is all about making money, too. Not just building cool stuff because we can do it in C++ and make it really fast. It's all about making some money. Because I can put this up on the store and sell it. And you want to support all these states. One of the things that the PM, and if you're a PM, I'm sorry, but I'm going to make this statement. PMs love to cut scope so that, because devs like to tell them, oh, it's really going to take a long time. And the first thing they go is like, well, we're just going to cut this out. Well, our PM decided they were going to cut out snap mode. And what he didn't know was you can't cut out snap mode. There's no cutting out snap mode. So support all the states, because people are going to try, and it's really annoying if I have it in portrait and it doesn't go to portrait and I have to do this to read your app, or if I put it in snap mode and then all of a sudden it doesn't do anything interesting and it kind of just doesn't do anything. That's annoying. So what this Visual State Manager in XAML does is allow you to decide or set up ways of things to happen when these states happen. This is tied to that layout aware page. So what will happen is it'll trigger one of these state groups to change, and you can create these storyboards. And think of storyboards as a way of defining what happens when something else happens. So if I say I go to portrait mode, I'm going to define this storyboard that says, hey, I'm going to switch from maybe a grid view. And if you have never done XAML, that's what a grid view is, just a way of looking at things. When you saw all of our pictures out there, that was a grid view. And I'm going to switch to maybe a list view and have it be a different view on top of that same data. And then I'll just show a list view grouped up together. And you can do that right in the XAML, and that storyboard could say, hey, when I do that, I'm gonna collapse the grid view, and I'm gonna make the list view visible. And I could do that with saying, hey, during that visibility, and please don't do this, but you could do some crazy things like do that over a 2-second transition. That would look weird, but you could do it. Maybe that's a cool thing. I don't know. I'm not a designer. And then, again, this was a big one. I think I've talked about this, and this is a big one, and I'll keep harping on this one. Keep that UI responsive. When you're navigating, when you're doing things, think about it. We had some like 11 meg, 28 bazillion pixel pictures that we put in here to go, hey, what happens when you navigate this thing and you want to see that picture and it's not going to immediately show up on the screen. We need to kind of read it from the file system. We need to display it. There's a lot of things that go on there, but we don't want to just keep that thing frozen while that happens. If you decide to change your mind in the middle and you go back, that's fine. So keep that UI responsive. And again, you can see we're basically doing that by doing a lot of stuff async. You'll see, again, you can see even when we wrote our functions, I would recommend you do this, follow the kind of this convention is we wrote the functions like get photo for data range query async, and we passed it a query. We're actually naming all of our asynchronous functions async. That way, when the developer comes along and he looks at it and he says, oh, this is async, just like in Windows runtime. It's async, async, async everywhere. And then we can do the bunch of tasks, do the thens, return that, and actually show that picture in that UI without, and they could change their mind in the middle of it, and we'll just go back. And we keep up with all the cancellation tokens, just like I told you to keep them consistent. We actually keep up with all those cancellation tokens, know where they should go, how they should cancel, so that if you want to cancel these operations, you go back, we just cancel them. Sometimes we don't because it's such a short operation, it's not a big deal if it kind of runs over, but be consistent in when you do. Woo. So the next kind of big thing is this MVVM pattern. So I don't know how many people have actually have seen this before, but you might have heard of MVC, which is Model View Controller. Well, MVVM is basically the same, is a similar thing, but it's done a lot with XAML. This kind of pattern came from the Blend guys. If you haven't seen Blend, it's a good tool to design your XAML. It allows you to do all kinds of cool stuff and styling and things like that. But what it allows us to do is kind of separate out easily what are the things that we can write as that have to be like public ref classes. Remember where I said you want to keep those to a minimum? What can be our models? What can we model out in just C++? These view models are just attached, and we do things called data binding. And that might sound eerily familiar. If anybody ever worked with Visual Basic people, they were like, oh, give me something to data bind. I'm like, and just drag and drop controls onto the screen. And we were like, hardcore C++. They were like, oh, we don't do that. But data binding is a very cool thing in XAML. And it's kind of one of the keys of keeping your views and your kind of models separated without kind of munging the two together and having these hardcore dependencies between the two. This view model kind of gives you a layer between that and says, all right, I can bind stuff to text boxes. But the cool thing about data binding is when I bind these things, they can be different two ways or one way. So I can say, hey, if I update in my code the text in this property, it'll get displayed on the screen without me having to write any code. That's the cool. There's all kinds of cool stuff like that with data binding. So what we did was we built this pseudo MVVM layer into our stuff, and we did a lot of code. I won't go through all the code, but there's a lot of code in there that kind of hooks up what they call the data context. This is the thing that gets attached to the XAML that says every time you see a binding operation, use this object to bind to. So if I had a data context of foo and it had a property of bar, and I had a text box that was bound to bar, it would just show whatever is in bar. And we did a lot of stuff with that layer-to-where page. We actually added our own. I love object-oriented programming. We added our own Hilo page, which was before, which actually does a lot of the work of hooking all that data context and views models and everything up. So if you ever want to do this yourself, if you kind of, or when you do build your Visual C++ app and you want to do it MVVM style, you can just steal that code because it does. It basically, if you do it this way, it makes it a lot easier. So basically, all you focus on, we kind of wrote a bunch of plumbing, and it's very lightweight. We wrote a bunch of plumbing so that you don't have to deal with. All you did was the view models and writing your XAML, and then it hooks all those things up together for you. As long as you follow that pattern, it just hooks them all up together for you, and you don't have to worry about it. And it made our life a lot easier once we got to that point, because we were doing a lot of kind of jumping around trying to figure out how to make this work in a way that would be good, but we did this. So, number 10. And I think the thing said 18. There might be a few more just as like extra gifts, just like you got Surface and stuff, so there might be a few more in here. But this bindable base, this is the thing that I was talking about with data binding. Bindable base is a class that also comes for free out of the box whenever you create File New Project. Or you can, whenever you create something inside there, they do a lot of stuff to get these classes in there. But you always want to put that on your models and things to support this idea of data binding. The reason for it is because it actually allows you to do something called notify property change. And what that does is, when I told you there was this two-way binding, and you said, all right, what's the magic behind this? Well, there's no real magic. I still have to tell the view that this thing changed. But I don't want to have a reference to the view. You remember, we want to have this loose coupling in our code. So I just say, hey, system, and I notify it with this event. I just call this function on property change, and it fires an event. It says, hey, by the way, this property changed. And it uses the name in a string and says, hey, this property changed, and I now go off and update that property on your view. And this bindable base class does all the work for you. So you inherit from this guy, and you're done. And then a little bit what I was alluding to earlier is you can use this pattern to help you figure out, what do I want to be interop ref classes versus what do I not want to be interop ref classes? When we first did this, when we didn't do it this way, we made a lot of mistakes because we were just making everything ref classes. We didn't know what we were doing. We were kind of flailing at the wind. This was all new to us. We were all like desktop C++ developers. We were like, oh, ref classes, we can just create these guys everywhere. That's not true. So what we did is we said, all right, we need to create some models that are ref classes. We need to create these view models that are ref classes because when you do all this stuff with XAML, it has to be a ref class. But we can do a lot of the file system and models of the file system and pictures and things like that as pure C++ classes. And it gave us a clear boundary of, here's where we can, this ABI boundary, here's where we create ref classes, here's where we don't. There's some, again, these are guidelines. They're not hard and fast rules, but they help us kind of visualize how we do this so that we can say, hey, there's the place where we put our ref classes and not. And we will be able to really increase the performance of the app when we got rid of a lot of the ref classes that we were using before. So we had all these ref classes everywhere, and we were like, oh, this doesn't work like we're not getting what we think out of this. So we redid a lot of it and refactored a lot of the code. Well, I shouldn't even say refactored. We rewrote a lot of the code to actually do this way, and it gave us, A, it was architecturally made it a lot easier for all of us to work in, and B, it was clear what should be ref classes and not, and we ended up with a lot less ref classes. So, world ready. So we don't all speak English. I speak a few languages, C++, C#, Ruby. You guys laughing, I know. But the thing you want to do is when you go out and build these apps, you want to make sure that it is world ready. You want to make sure that you don't hard code any values in there that are about screen sizes and things like that, because Windows 8 is all about a Surface, a 50-inch screen, my laptop display. I mean, there are some hard and fast rules about what displays it will, but you can put this anywhere pretty much. And you want your app running anywhere. Don't you want out in the front of the Microsoft Store to put your app out there and it be running in front of the Microsoft Store so that everybody buys your app? That's what I want. So make sure that it's world ready. And XAML makes this relatively painless. I remember doing this for localizing applications on the desktop, and it was painful. I figured out how to do it, and so it became less painful. But this makes it really easy. So you can actually separate the resources for each file. So you can see this is a version of the Solution Explorer in Visual Studio 2012. You can say, here's how you do resource strings. You put a bunch of stuff in there. It's really cool. You can actually say, here's the actual, there's stuff in XAML, and if you haven't had a talk on XAML, you should go on if you don't know a whole lot about it. But there's a bunch of stuff in XAML that says you can give it definitions, and it will pick them up from the resources, and it will then display that text as a resource. So if you, for default English, you saw up there we said like pictures. Well, that actually has a resource associated with it that not says pictures. It just says something in the resource file, and it picks it up from the English US because that's what my locale is set to. Makes it really easy. Now, I can't write out all those crazy or read any of that. But the people who can, and those have the locales, that will be done for you. And use the calendar. The calendar, and I will tell you why, because we screwed this up too. We didn't realize how to use the calendar correctly, but we did, and that's how we get all the, when the file system, and I showed you saw in the app where it kind of put everything by month, and a lot of this file system queries, you can actually do that now. The file system does that for you. But you can say, oh, here's all these things by month, and then I've got all these dates associated with it. But how do I do that in a world-ready view? Well, we have to use the calendar to get all that stuff done. So we use the calendar. We actually say, here's the year date that we want, and say, all right, now give me the number of months for this year. Because it's not always 12, depending on what calendar and things that you're using. So we take advantage of that, and we say, use that calendar, now give me the number of months in this view. Because you remember when I zoomed out, and you saw the calendar that we built, which was, again, we spent a lot of time on that because we wanted a good experience for people to, beyond just zooming out and seeing a bunch of pictures. Kind of when you zoom out on your start screen, you can see all of them. We wanted something completely different, which you can do. And we said, oh, we want a kind of a calendar so that you can see and pick. And we use the calendaring system to do that. So since this is probably one of the toughest things that we did to get, and it was really hard to get right. You can see by this picture, this is one of the pictures, again, when we built this, we worked in a team room and we had white walls everywhere, and we wrote all over the walls. This is kind of stuff we wrote all over the walls. How does suspend and resume work? So we could remember, how does this thing actually work? And it's pretty easy once you get down, but it took us a while of drawing a bunch of pictures to figure it out. And you guys get the benefit of, now we just tell you, and you guys, oh, okay, that's how it works. You don't go through all the pain that we did. But it's basically, I can have a running app, and remember, when I'm having a running app and you've all got your surfaces, I can run it, I can just, whoop, gone. But it's still there. It's still running. It's just suspended. Now, that suspension will last as long, and that suspension will last as long until the OS decides to terminate you. It's totally random when it will happen. It'll just say, hey, I'm low on resources. You seem to be looking like a resource hog. I'm going to take you out. Thanks, OS. And it terminates you or suspends you. Or if you're in suspended mode, you can just reactivate. And you've seen, like, I can go activate, and I'm back at the same exact page I was. But we did a lot of work to do that so that you know what to do when you suspend and resume. And, like, I'm going to save my state. I need to resume my state. And I can get rid of resources. And I'll talk a little bit about how that works. So I'm not going to go through this whole thing. But this is kind of the model that we drew on the board as well to say how we were going to do suspend and resume in our app. Because you have this global suspend and resume kind of, hey, I got notified that I'm suspending. And I've got to go through and say, hey, and it's asynchronous. So I'm going to suspend. And I need to go through all the things. So a lot of the stuff that we built in that Hilo page and the layout aware page does some work for you. And it has some suspension manager. But what we did is basically say, at the Hilo page level, we say, every time you navigate, we're going to get state and save state so that you can, at any point in time, if the thing got suspended, we kind of have this this map of string and objects that we can persist and save state on. And then so what happens when you suspend, we can get rid of a bunch of the pictures and screen, but then we can suspend where you were. So we keep up with that query that you had, which is basically the picture that you were on, what maybe date you were on, what page you were on, so that when you come back to the app, we can kind of rehydrate everything for you on the resume. But this suspend basically goes through the navigate. It then goes through a bunch of suspension. It saves its state, and then it writes it all out to a file. And actually, it's pretty easy. Once we figured out that part, the reverse happens on resume. And make sure, and that way, when you save that state, that you are actually resuming and giving them an experience that says, hey, now I'm back to the exact same place I was. It took a long time for that because we also had the PM go, hey, can we just cut that feature too? Because they were like, and we were like, no. Like, that would be an awful experience if every time you started the app, you started on the same page. You're like, oh, I'm back to the home page. Well, why am I back to the home page? Why did I have to get back there? Why can't I just be back where I was? And we thought that was a good idea that you should be back to where you were. Now, we spent a lot of time doing that, and there's a lot of code in there that we wrote to do that, but a lot of that came from that layout aware page and some of the Hilo page stuff that we did to actually so that we could actually have the state save in the view model. Because again, we wanted to separate views from view models so that we could actually do all that work. And the big thing is, if you don't want to be terminated, release those resources. Because if you don't have any resources to, if you're not using up gobs and gobs of memory, it's doubtful that you'll get terminated. They'll just suspend you and you'll be in that same state. Because when you get terminated, you will start back at the home page. But it'd be great if you could keep yourself in that suspended state for as long as you could. So what we do is we actually release all those pictures, everything that we can get rid of. We basically tear down everything that we can to basically release all those resources, and we save that in that state. We just save pointers to files. We save all this stuff. Remember when you saw that code in there, it said, if the photo is null, go home? So what happens when I woke up and the photo got disappeared, when we had to think about these things? Like, what would happen? Oh, we need to go home. Go back to the home page and let you start over. Touch language. Now, you saw me, I was using a mouse. But you guys all like surfaces. I don't have a surface, but this thing works with touch too. And it's really cool. Like, we all got big touch monitors, and we did get the PM to buy us touch monitors. And we were like, hey, we want to be able to touch and go through and slide because we wanted to do that. And one of the cool things, one of the features you have is we actually show you, we do crop and rotate and cartoonize. We kind of said, we want to build this pluggable piece that you could plug in different adapters that said, hey, well, you could do different things to a picture. It's not Photoshop, but something like that. But one of the ones we did was rotate. And it was like, how do you rotate a thing? Like, we need to rotate it with a mouse and a keyboard and touch. So we had a button to rotate it. You could then you could take two fingers and gestures and say like, oh, flip this way. Or take your hand and flip this way and do all kinds of crazy stuff. Or flip it back this way, and it would flip, flip, flip. You could flip it around. Got a little dizzy watching the thing. But one of the other things we noticed is that when you do touch points, for example, if you want to show a little tooltip above the mouse or above things, make sure it's above your hand. Until we got those touch screens, we had the mouse down and we had a little tooltip that showed you a picture, a small picture of the picture and like information about it, like its file size and anything that we could get out of the file system about the picture. Well, when we did it with our hand, we were like, oh, we can't read that. So make sure, so you can see here, we actually just kind of negative up the pixels to where it paints so that it's always above your hand a little bit. We assume that it's going to be above your hand. We went enough. We did a lot of testing with different people's hands. If you do it like this, it probably won't work. But as long as you're touching it like that, it's OK. And use the standard controls. A lot of the stuff that you'll get, that the Windows Fluid and how things work in touch and how all the things in Windows 8 work, comes standard if you just use the standard controls. Now, there's nothing stopping you from using like DirectX on a XAML surface. You can do that. It's really cool. And you can do a lot of things like that. But when you use the standard controls, this is basically, looks pretty much like the stuff I showed you on the screen. We got all those for free. All that stuff we built for free. We just used XAML and controls and put it all together and said, hey, we got all the touch stuff for free. The tooltip was the one thing we'd noticed. But we got all the scrolling and panning with our hand versus the mouse versus the keyboard. And big thing, make sure all those things work. Remember, everybody got, did you guys get a keyboard with a touch, with a Surface? Man, I didn't get anything. So that's awesome because remember, you don't just touch. Like the cool thing about this new world is like I can touch and I can type and I can use the trackpad and I can do like I'm not bound to one or the other. I can do all kinds of interesting things, but so make sure it all works. It's a little harder, makes it a little harder on you, but if you use the standard controls, 95% of the time things just work for you. And we learned that the hard way too. Mostly because we tried to do some custom things because we thought we had to, but we didn't have to. We ended up using all standard controls, except for a couple of little things, one-off things. Tiles. So tiles are a big, huge thing. You want to see your app alive. Like it's really cool to, like, except for my weather app. I live in Seattle. I know exactly what the weather's going to be. 50 degrees and raining, 9 months out of the year. Those other ones, that's really cool to use, but other times it's 50 degrees and raining. But tiles kind of help your whole thing come alive. And I say, so we wanted to have tiles. And we wanted to go, hey, we want to have all your pictures scroll through, just like the regular picture app does. The funny thing was we actually worked with the Windows team, the guys that built the actual Windows app, the Windows photo app. So we worked with those designers and those guys because, we're not designers, we're devs. We actually worked with those guys and we said, all right, what should it look like? That whole calendar thing, that's what they wanted. So they said, oh, you make it look like a calendar instead of just like a bunch of pictures. Like before, I haven't seen it since they did the update, but before you just got, picture, 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 you slide through and then you could see all the pictures. They wanted to see a calendar, so we did. And one of the other things they said was that we want to be able to see like a bunch of recent pictures right inside the tile. So we said, okay. So we wanted to put it on a schedule and flip through it. And so we did. And when we started this project, we thought that was going to be the hardest thing. Well, it was, but we only made it hard on ourselves. We thought we were going to have to do all the scaling of the images and all this other stuff because we were like, oh, wow, you got to put all these images and then we have to make, and then we thought, oh, man, how are we going to get all of them in this little box to make it look like 5 little images and all that stuff? We were like, oh, the Windows runtime already does that for us. We didn't know. But now when we did, and after we threw away a bunch of code, we figured out we can do all that scaling. The Windows runtime does all that scaling for you. You can just give it bitmaps and things like that and tell it to scale it. It says, no problem, I'll do that for you. Check. We didn't have to write any, like there's a template in there for doing tiles. You just ask for that template, and it gives it for you, and you're like, hey, let's do, give me the template for a wide tile with 5 pictures in it. And it goes, okay, give me the 5 pictures, done, check. Wow, that was a lot easier than this massive code base that we deleted. And that's one of my favorite things to do is delete code, because if I don't have to maintain it, that's even awesomer. Now, file system. File system is pretty cool. There's a lot of cool things you can do with it. I don't know if you guys played around with it, but you can send it. You can do crazy things like send it queries about like, now give me my files by month, group things by name, group things by this, and it's almost this whole query. It is a whole query language that you can use to do things with the file system. Made our job a lot easier because we basically sent in a bunch of queries. That's the stuff you saw a little bit in the code, and it was really easy to get files back from that pictures library. But you want to make sure that you got a lot of perf. There's a thing called bulk access queries that you can do because we were getting a lot of stuff. There's an indexer that you can turn on and off that you can make sure that when it's available you will use. And you only prefetch the things that you care about. So we cared about a thumbnail image, we cared about the name, we cared about the date, and so we only said, give me the things that I care about. And if you do that, you're going to get a much better performance out of your app, because we used to get everything, and man, did it become slow. Because we tested this, I think, with, I'm trying to remember because it was a few months ago, but I think we ended up testing it with like 20 gigs or so of pictures, and it was quite responsive. And that was one of the big things that we did. And this is why we all love C++. We all want to drive a drags car. We all want to go from one red light to the other really fast. So keep those launch times of your app fast. Make sure this is the big one we suffered. When we were doing this, we said, how are we going to make sure that those tiles get updated? Because you can imagine, when you first start the app, you just installed it, and everything's brand new. There's nothing on the tile except the Hilo image, and then you start it. You're like, oh, we got to go get all those images. We got to grab this big batch size, and we got to do all these things with it. We got to cut them down, and we need then say and give them and update the tile. How are we going to do all that without locking up the entire app? Well, we just wrote a bunch of tasks to do that and scheduled it, and it was pretty easy. So I want to show you that code because I actually think, we've gone through a lot of slides, but I want to show you a little bit of that code here just to kind of give you a taste of what things look like. Hopefully so let's go back. Where's my desktop? There we are. So this is, just kind of give you a little look peek. This is Hilo. So you can download this. It's part of the Windows SDK. We try to be very good citizens. We also, if you've not noticed, in Visual Studio 2012, you can do unit testing with C++ now. This was something I was sorely missing. We had to you pretty much had to go, get your own, set it all up, put it in the right directory, make sure everybody using the same directory structure and things like that. But now you can just do it right from within Visual Studio. And we actually have unit tests for all the code that we wrote. Which is kind of cool. So if you're interested in writing unit tests for Windows 8 apps for C++, there are lots of code in there that you'll want to steal because it's not as intuitive as it seems to be. But that's a whole different talk. But the code for the tests are actually up on Codeplex because we have a whole Codeplex site. So if you get some of this code and you find problems, you don't like it, you want to yell at us, or if you even want to say how great of a job we did, you can put it up there on Codeplex and give us that information. But here is, and we broke everything apart. We like using these little folders because we like all the stuff to know where everything is, because I like, I'm a little OCD. I like tidy little things and put everything in their place. But when you start out, it is app.xaml that basically starts you out, and you can have app.cpp, which is what we're looking at here. And this is where all these events happen that you get notified. One of the big first ones is this guy happened to launch. And you got launched the app. So we actually go out, get the root frame, which is a lot of stuff about how XAML and things work. And a lot of this code is boilerplate. It actually comes from whenever you create file new project. We all register the frame with the suspension manager, have it do its thing. We determine if it had been terminated or what the previous state was. We assume if we can't do anything with a state, it just blew up and we just go on with our life. And just activate the window, and we then come down here to activating the window, And then this is the part where we go and say, hey, once all that's done, go off and in this tiles update scheduler, and basically go do a bunch of tiles. And if you look at this guy, he's just a C++ class. That's all he is. And he schedules the updates asynchronously, and he basically goes through and uses a couple of little objects to update the schedule, or update the tiles, build them, put them in the background so that when you look at the app, this is what you get. You get a bunch of tiles, and eventually it will scroll through, and you'll see that scroll back and forth. And that was my trip to Berkeley, and the Disney Wonder was docked right there, and I was like, holy crap, it's Mickey Mouse. So I've got one last bonus for you. Read the guide. It is part of the SDK. It is out there. There are so many tips and tricks in there, and goodness, it's the whole ball of wax. I could never in an hour tell you everything. I gave you the high-level stuff that really tripped us up when we built this app, but everything that's in there is awesome, if I do say so for myself. And if you have a chance, go see the future of C++, because it's here. It is now. And you should be loving it and living it. And there's all the links. And I'm going to open it up for questions. If anybody has questions, please ask away. Yes, sir. So the question was, is the guide that's part of the SDK specific to the Hilo project? It is specific to the Hilo project in such that it describes our journey through building Hilo. But it is very specific to how you build these apps with C++ and XAML, and this new modern way of building Windows Store apps with C++. Yes, sir, right here.
Do you guys have any kind of story on connecting to external devices? Let's say you have an external device connected via USB.
So,
Drivers, things like that.
yeah. So the question is, how do we have anything about connecting to external devices, or how you would do that? The answer is no, but there is we do have a bunch of pointers in the guide that talks about when you want to do devices, because a lot of that stuff is handled by the Windows runtime of the default devices that have in there, but I don't think we talk about anything like if you're going to build a kernel mode driver. We don't have anything in there about building kernel mode drivers or anything like that, and I'm not an expert on that, so so hopefully that, sorry it wasn't more helpful, but there is lots of documentation that we point off to that will help you do that. Yes, sir, right there.
So a couple of times I noticed that you're using ref, vector, capital V.
Yes.
I think that's different from standard vector. So when is it that we should use the ref vector versus standard vector, or can they be used interchangeably?
Great question. The question was, he saw that we used ref new vector hat, little caret at the top. That's a hat when you're using ref classes in C++. And the question was, when do I use a vector versus a standard vector? How do I decide when to do that? So the answer to that question is, if you need to expose things across that ABI boundary, use vector. And actually, you actually don't use vector. You're going to use an I observable vector or I vector, and vector actually implements that. It's just an H file that has all that in there. And actually, they're interchangeable. They're pseudo-interchangeable. So you can take a vector, a standard vector, and pass it to the constructor of a vector, and it just works. Everything is, so they're meant to work in parallel. And and that is also true for maps and a couple of other things. So
So when you go from standard vector to vector in the constructor, are you making a copy or are you getting some kind of a, you have some kind of a reference back to it?
so the question was, am I making a copy or some kind of reference back to it? It's a reference back to it. There's no copy in there. And then you can go see all that code because it's just part of the SDK. You just click on vector and hit F12. You can go to it's in collections.h. You'll see all of those defined in there. It's all the code. Yes, sir. Back in the back.
Did you have any surprises mixing C++ exceptions with the async task model?
Did I have any surprises with the C++ exceptions and the task model? I don't remember any offhand. I do remember that debugging tasks are not the most fun or easiest thing to do, but they do have a lot of cool new updates with Visual Studio to do that. I think he has the answer right here.
Continue on the task of the return value, not just the return value.
What?
Catch exception.
Right. So when you can, yes, and maybe he was talking about this, and maybe I'm going to say this a different way, but there's two ways to do tasks. You can do value-based or task-based continuations. And if you do a task-based continuation, you can call .get to handle the exceptions. But if you do value-based continuations, it's just going to throw if it throws an exception. So if I have task 1, and I say task1.then, and it returns a vector of ints, and I capture in the Lambda to return vector of int, but that function throws an exception, the whole thing will just blow up. But if I create and get a task of vector events and then call .get on that task, I can then put that in a try-catch and deal with the exception inside of the then statement. Maybe that was what you were trying to say, and hopefully I explained it in a way that made sense.
Yeah, but your stack traces are typically going to look funny because you're running an arbitrary thread.
So the statement was that my stack traces will look funny, and that's where the fun begins, because there are ways to get back to the stack traces that we do have. There are whole tips in the actual guide that shows you how to deal with this parallel programming and dealing with stack traces, because you can get little tokens, and then you can take that token and put it in the exception window, and it'll give you a better stack trace of where things go, and you can also use the parallel window now to debug these parallel things. But that was when we were doing tasks and we were debugging this was back in RC and pre-RC days, and that didn't exist. It was fun. You guys got a lot easier now. Any other questions? Apparently, I answered everyone's question. Oh, wait a minute. Over here. Sorry, I missed you. I'm blinded by the light.
I'm assuming that practices that you do would fit in the normal 5-second suspension time. So how would you have handled, let's say, that if your image processing, let's say, would require, let's say, a minute to process, and before you basically user started it, seeing that it takes a long time, and just starts other app without thinking that it's effectively suspending. How would you handle this suspension? Because now you are trying to process image,
Yep.
not just remembering position.
Yep.
You already started processing image.
So his question is, so let's say within that 5-second suspension time, like you have so long to suspend your app, how would I deal with something that maybe took a minute to, like if I was processing an image? Well, that's where the use of cancellation tokens come in. So what we do is we say, and there's certain things that we can't do depending on how the happens. We actually do that cartoon effect in processing that image with AMP, and we go back and forth to all that code we own. We can pass those cancellation tokens around, and we can say, and we also within that suspension, that's why we pass it all along to the view model. We take those tokens and we keep a member variable of it, and if we get suspended, we cancel all those operations that are happening in effect. So that's how we dealt with, like if it was a long-running task, so we would cancel that task. And we would hopefully have that task cancel itself, but eventually if not, I'm not 100% sure, but. Right. So there is a little bit of a surprise there. So it's a trade-off. Like it's like, what do you want to do versus what can you do? And I think you have to do the right thing for your app. So there's no hard and fast rule there. Right. And yes, only once, yes. I mean, it depends on how long it takes. Like I would, like while it's suspending, I might leave that running for, like in my code, I might leave that running for another second or so, but it all depends on how you want to do it. But most of the time in our app, we just would cancel everything because we were assuming that, you moved away, you must not want to wait that long. Maybe you want to go do something else. Our assumption is you're going to go do something else, you don't want to wait for it. Or your assumption could be that I'll just go until I can't go any longer. There's no hard and fast rule there. It's a great question, though. Any other questions? All right. Well, thank you very much for coming. Hopefully this was informative. Please go download the SDK, download the guide, take a look, write some great apps.